Hello, I'm Wafer Agent. Today's video is a little different. When most people think about semiconductors, they think about silicon wafers. But to manufacture a single semiconductor device, you actually need dozens of critical materials. Some materials draw the circuit patterns, some deposit the metal interconnects, some polish surfaces to a mirror finish, and some make AI semiconductor packaging possible. Today, we're going to cover all of it, from wafer to package, the essential materials that drive the semiconductor industry, all in one place. Chapter 1. Silicon Wafer. Every semiconductor starts here. High-purity silicon extracted from sand grows into a single crystal ingot, which is then sliced into thin wafers. A single 300mm wafer can yield thousands of chips. Key makers include Shin-Etsu Chemical and Sumco from Japan, the top two globally, along with Global Wafers from Taiwan and SK Siltron from Korea. This is the starting point of the entire semiconductor industry. Chapter 2. Photoresist. This is the material that draws the circuit. No matter how advanced ASML's lithography scanner is, without photoresist, circuits cannot be formed. Key makers include JSR, TOK, and Shin-Etsu Chemical, all from Japan. As process nodes continue to shrink, photoresist becomes an increasingly critical material. Chapter 3. Photomask. The photomask is the master template of semiconductor circuits. Lithography equipment projects circuit patterns through this mask onto the wafer. Key makers include Toppen and DNP from Japan. A single defect on a photomask can render an entire wafer defective, which is why quality control here is absolutely uncompromising. Chapter 4. Specialty gas. It's not an exaggeration to say that semiconductor fabs run on gas. Etching, cleaning, deposition, specialty gases are used in every single process step. Key makers include Air Liquide from France, Linde from Germany and the US, and SK Specialty from Korea, the world's largest producer of NF3. Chapter 5. CMP Slurry. Semiconductors are built by stacking layers. But if the surface isn't perfectly flat, the next process step cannot proceed. CMP slurry is the critical material that planarizes surfaces down to the atomic level. The leading maker is Fujimi from Japan. Chapter 6. Sputtering target. The metal interconnects inside semiconductors are deposited using target materials through a sputtering process. The leading maker is JX Metals from Japan. Chapter 7. Silicon Carbide, SiC. From here, we move into next-generation materials. SiC offers superior high voltage, high temperature, and high efficiency characteristics compared to silicon. Electric vehicles, industrial inverters, and renewable energy systems. SiC adoption is growing across all of them. Key makers include Wolfspeed and Coherent from the United States. Chapter 8. Gallium nitride, GaN. GaN excels at high-speed switching. Fast chargers, 5G base stations, RF amplifiers, and data centers. GaN adoption continues to grow across all of these applications. Key makers include Navitas Semiconductor and Infineon. Chapter 9. ABF Film. This is the most talked about material in the AI era. ABF is essentially a prerequisite for HBM, GPU, and high-performance packaging. The sole global supplier is Ajinomoto from Japan. When ABF supply tightens, GPU production bottlenecks follow directly. Chapter 10. CCL and copper foil. Package substrates start with CCL. Copper foil is laminated on top of the CCL, and circuits are formed from there. Key CCL makers include Panasonic, EMC, and Isola. For copper foil, SK Nexelis from Korea, Circuit Foil from Luxembourg, and Mitsui from Japan are the leading suppliers. Copper foil is laminated onto the CCL, and circuits are formed from it. The thinner the copper foil, the finer the traces that can be achieved, enabling higher integration density. SK Nexelis from Korea is the global leader in both semiconductor and battery copper foil. Chapter 11. Glass Core. This is the next-generation material generating the most discussion right now. Glass core offers higher integration density, lower warpage, and superior signet characteristics. It hasn't fully replaced ABF yet, but it's the leading candidate for next-generation packaging technology. Semiconductors are not made from silicon alone. Silicon wafer, photoresist, specialty gas, CMP slurry, SiC, GaN, ABF, CCl, copper foil, and glass core. Dozens of materials come together to complete a single semiconductor. Technology competition is ultimately a materials competition. Over the next decade, which materials will define the semiconductor industry? Let's watch it unfold together. Thank you.